Got it. Yep.
We are being live streamed. So hello, everybody on YouTube as well, and everyone here. Welcome to this financial markets special interest group. And I think we've got a bit of a treat today. We have Mark and Balaji from Oracle, who are going to talk a little bit about what they're doing in Fabric in financial services and Cbdc applications. And I think, shall I just hand over to you now, Mark, and you can take over, and then please, everyone have questions ready. And if you're on YouTube, I'll be watching YouTube as well. So any questions there, I'll pick up as well. Okay.
All right.
Over to you, Mark.
Great.
Thank you.
All right. Thank you, Julian. Thanks very much. So just a couple quick introductions. I'm Mark Rakhmilevich. I'm responsible for blockchain product management at Oracle. And with me, we have Balaji Kalyan, who is an industry innovation advisor for financial services. I'm based in San Francisco. Balaji is based, or San Francisco Bay Area at least. Balaji is based in India, and between us, we covers the world. So we have a couple interesting topics on the agenda today. I'll just briefly introduce Oracle's kind of strategy and our blockchain capabilities. Obviously, the platforms that we built around Hyperledger Fabric. I've been a member of Hyperledger for a long time. At least since I believe 2017, if I'm not mistaken, and he has a platform that was out in the market for at least 4 years, since 2018. We'll highlight some of the innovative capabilities. We have been doing a lot of work to continue to innovate with the platform and provide a lot of valuable features and capabilities that particularly financial institutions really appreciate, also customers in other industries. But today we're talking about financial institutions, banks, etc. We'll touch on our tokenization support, and then Balaji and I will cover some of the more interesting use cases and projects that we've participated in financial services. And then we'll also talk about Cbdc in particular, because there is some exciting work happening there, and some of the capabilities that we've been investing in, I think, are going to be very useful, leveraging core Fabric capabilities and the tokenization support we have built on top of it. So let's get started. Oracle, as I mentioned, had been investing quite a lot in this space. We believe that there is a very significant opportunities for enterprise blockchain, and I emphasize enterprise because Oracle customer base, of course, are not consumers, right? It's other companies, government organizations, etc. So we're thinking about it in terms of business and organizational networks, helping to either create new ones or significantly optimize existing networks by using blockchain capabilities, namely single source of truth, distributed ledger, trusted transactions, and all the rest of it, right? But it is a complex technology that has a lot of moving parts. So our focus in the market has been to make it easy and quick to adopt, provide a really leading enterprise blockchain from a kind of infrastructure perspective that enterprise IT can get behind, but also something that developers will love because of the development experience and automation and tooling available for it. It's a platform that's available in a cloud environment, in Oracle Cloud, OCI, as well as on premises. So we cover both grounds, and we can, of course, run them together as a hybrid network as well, if necessary. We have built also some SaaS applications focusing on the most common supply chain management use cases, intelligent track and trace, and there's been some interesting adoption in supply chain space. Both the platform itself, a custom solution built, as well as this business-ready solution. And we've been doing some work in database as well, what we call crypto-secure data management, inheriting some of the core techniques and principles from the blockchain, but applying them with an Oracle database as well, to make it easy, for customers that are using database to benefit from those capabilities as well. So, very quickly, our platform, as I said, Hyperledger Fabric, but as a managed service, right? Blockchain as a service. So it's all pre-built, pre-assembled with all of the underlying dependencies that you need, all of the Hyperledger Fabric components, peer nodes, ordering service, Fabric CA membership service. But we also provide a very extensive set of operations tooling, web console and DevOps APIs, API gateway for integration, events, subscription, and event callback delivery. So a lot of integration work is done through this API gateway. We integrate with Oracle database to be able to stream transactions in real time into a database relational schema for analytics and other kind of use cases. We have done a lot of work, of course, to integrate this blockchain and provide tooling, not only REST APIs and events, of course, native Fabric is the case, but also a lot of integration adapters out of the box for various systems of record, ERP systems, Oracle and non-Oracle, in cloud and on premises, and various enterprise technologies. We maintain full compatibility with other open source Fabric or Fabric from other vendors. And we have, in fact, in production running multi-cloud networks with some of the other Hyperledger members for some of our customers' use cases. A lot of enterprise-grade features built in: dynamic scalability, high availability, resilience, security, auditability, many other things that over the years enterprise customers have really pushed us for. A lot of automation through DevOps. And then last couple of years, we started focusing beyond infrastructure to make it easier for developers who are actually building applications. We created this tool called Blockchain App Builder, which provides out-of-the-box capability to automatically generate chain code from templates, from specifications. And that way, you don't have to rely on expensive blockchain developers. You can actually use people that maybe they're comfortable within the domain space and some basic enterprise kind of development work. But you could, in fact, generate chain code and deploy it without even any development programming experience. Of course, you need to do some testing with it, but it's all exposed through the APIs, REST APIs for integration, pre-generated from the app builder based on the templates that you can tailor to particular use cases, and so on. So it's kind of a low-code, no-code combination. And we have added support for tokenization in this as well. So you now have fungible tokens and non-fungible tokens, NFT support available that you can automatically generate from this blockchain app builder and then deploy into the blockchain platform. So all of those capabilities come kind of pre-assembled in one place in Oracle Cloud environments. If you go to Oracle Cloud, you'll find blockchain platform under developer services. So that's fundamentally what the solution looks like in a cloud environment. And we have a similar thing on premises for people who need to deploy outside of Oracle Cloud, or maybe in the third-party cloud, right? Depending on some data sovereignty requirements in various countries or industries and so on. And it's run in VMware. You can run it in Oracle VirtualBox. Pretty much the same capabilities, same tooling, but without dependence on the Oracle Cloud for those customers that want to run it that way. We've done a lot of work over the years to not only exploit Fabric, but to improve on it by providing a lot of additional capabilities, right? So, of course, we make it run in a cloud environment, so there is basic provisioning, infrastructure dependencies, all pre-integrated, but things like automatic redundancy and replication, you can select an enterprise edition and you will get that out of the box, or enterprise SKU, dynamic scale up and scale out, and many other things. It's a managed service, so we do zero downtime patching and updates. Customers don't have to worry about any of the maintenance stuff. It's all done out of the box. We provide an operations console, which is a web UI, but also REST APIs for all kinds of administration and management. It's very intuitive and very easy to use, and also does a lot of monitoring, troubleshooting as well. We've done a lot of work around extended security, as well as auditability, such as fine-grained access control. That is very important for confidentiality. Some things that we'll talk about in more details: on-chain audit log, block integrity validation, those kind of things. Identity management integration with user and role management, as well as federation support using Oracle Cloud. The bidirectional API gateway, which I mentioned earlier, provide a very extensive set of REST APIs for synchronous and asynchronous transaction invocation, much simpler than using the client SDK. And at the same time, it enables subscription to events with callbacks, and then we provide the callback delivery mechanism. Talked about the blockchain app builder with auto generation of chain codes and token support. We've also improved on the data management. We've seen a lot of challenges with CouchDB from a performance and scalability perspective, and also just some of the functionality. So we use our own Berkeley DB, which is Oracle open source key value store. It's about 10 times faster than CouchDB, and we integrated it under the peer chain and under the peer APIs. But it also provides SQL support. So in our chain code, you could either use CouchDB query language, which we still support as a language, or you could use straight SQL select statements with where clauses, which is much easier. And this data pump I mentioned earlier, integration to Oracle database to basically stream transactions as they come in to the history database into Oracle database in parallel. for analytics, machine learning, data warehousing kind of things, and so on. Been very popular with customers to be able to do live analytics directly on the blockchain ledger through that mechanism. So a lot of this infrastructure work was great, but customers have said, we now have to spend a lot of time on applications and building use cases. What can you do to help us? So there are two things we've done. We have a portfolio of industry solutions. I'll show you some examples of those. A very rich ecosystem, but also tools that we built called Blockchain App Builder, which is a low-code development tool for custom application development. It manages and accelerates the development lifecycle in terms of development, testing, deployment, automation, all of those things. But one of the critical things that it does is automatically generating smart contracts based on declarative specs or templates. So you can take an existing template, you can tailor it, or you can add your own from scratch, and will automatically generate all of the CRUD methods necessary to do persistence operations on those objects that you define in the template, with all of the validations and everything else. You can add more code if you want to, or if it's a simple use case and you just need the persistence, create, query, update, delete kind of operations. Those are built out of the box, and you can use REST APIs to interact with them. When we initially released it, this was all for generic applications, but then we said, let's go ahead and create specific templates for tokenizations with the generated lifecycle methods for fungible and non-fungible tokens. So I'll talk a little bit about that as well, but we now have full fungible, non-fungible token support in the platform based on this automatically generated chain code methods for the token lifecycle. So that's kind of a very quick summary. Been rated pretty highly. This is from Juniper Research, putting us on top of the leaderboard. And some of the other analysts have also IDC and Gartner and so on. Rated us highly. A lot of production deployments. We weren't the first to come out with an enterprise blockchain, but we did focus on getting customers to production into live deployments and making it as straightforward and easy as possible for them to do that. So you see examples here in financial services. We'll talk through some of this in more details. B2B platform, Diamonds traceability. Hyperledger was a great example. And healthcare here, education, trade services, one of the largest networks actually based out of Asia Pacific called Global Shipping Business Networks. The joint venture is headquartered in Hong Kong, but they have, I think, 9 or 10 now major industry members from Asia, Europe, and US participating in this. This is all of the maritime shipping. And about one in three worldwide containers that goes from maritime shipping goes through their members through this network. So it's all of the logistics tracing documents and a couple really unique applications in this particular space. Food, manufacturing, electric vehicle batteries, there's a lot of materials and CO2 emission traceability goes along. We have partner solutions built by Circular for Volvo, Mercedes-Benz, and others. Loyalty solutions. This is again farming and agriculture for milk, and so on. Just a bunch of different examples here. I also wanted to show you some of the examples of the partner solutions that have built on our platform. Some are in pilots and others in yellow here are running live in various services. This is financial services, banking, financial services, manufacturing and field services, solutions in retail space, food, agriculture, and CPG, logistics and transportation. Some are based in, well, I talked about this one. This is actually built by CargoSmart, split off into the PsychioX subsidiary. Cargo exchange, a large deployment in India for export-import business. Education solutions, Snapper Future Tech is one of our great partners in India as well. Who else? Guillaume is a recent partner doing eKYC in India. I'm just trying to pick the partners. Tech Mahindra. Who else? This one, Coiners, India-based partner with markets and platforms they've deployed for Hindalco, which is a large metals manufacturer. Healthcare solutions, and then some tokenization and NFT solutions as well from partners that have been building on our platform, leveraging the NFT support that we have. So this is just a quick summary. I wanted to spend a few minutes going through some of the technical capabilities we have added to make this a go-to platform for many, particularly in financial industry, right? Fault tolerance is really important. And in Oracle Cloud, we deploy the blockchain platform across multiple availability domains. So a region is a location, right? So location like Singapore or Mumbai in India or Tokyo and so on, or in US, Phoenix and Ashburn and London and Frankfurt. And each one has multiple data centers, usually 20 kilometers apart. So when we provision enterprise shape, we provision it automatically across the 3 availability domains, right? Customers just don't have to worry about the details here. It's all out of the box, but you have resilience, right? So you have replicated services, and then you have peers and orders that you can split. And if your application is going to need high availability, then you make sure you send the request to peers in separate availability domains. And that way you're sure that even if one of the 3 availability domains goes down, you still have high availability. We can also do the thing across multiple regions, multiple locations, creating ordering clusters that are geo-redundant and can span that. You can also do dynamic scale-up. So you create an instance for particular size, and then you say, I need to add more capacity, more peers, more orders, more CPUs, more storage. All of that is dynamically scalable on request, on demand, basically. Pki and certificate management is very important, particularly for banks, right? So, you're familiar in Hyperledger Fabrics, there is a CA that's used to issue identity certificates and manage identity for all of the peers, for order service nodes, and so on. And typically, by default, it runs in the self-signed mode. But many banks have the existing CAs. And what they want to do is they want to actually run our CA as an intermediate CA. They already have intermediate CAs for different application areas. So they basically want to be able to run our CA here in AVP as intermediate CA under their root CA. So when you provision our blockchain, you can specify, you can basically upload a certificate chain from your root CA. And then we will use that in our CA to sign the generated leaf certificates, right? Identity certificates for peers on sense. So they're now all signed and roll up to the root certificate of your root CA. We also maintain a CRL, so certificates can get compromised or revoked. And it's important to be able to notify other participants in the network. So we actually have a mechanism where we can add certificates to a CRL and then distribute the CRL so everybody is aware that certificate's been revoked. On security front, standard, of course, cloud security, but then in OBP, Oracle Blockchain Platform Instance Security, we have role-based access controls that we've added. Of course, standard TLS, channel security, message signings, a standard fabric. We provide audit trail for lifecycle configuration changes, so that anytime you make a change in the configurations, that's logged. And then, of course, you have blockchain channel level ACLs and policies in Fabric. We supplement that by providing fine-grained on-chain ACL access controls lists within the chain code. So you can define resources the chain code relies on, functions or data, and then you can manage it based on identity patterns, based on certificates, attributes, groups, etc., and essentially implement enterprise level access control for fine-grained. We have one customer who is building a solution for financial trading, where there's going to be multiple clients, multiple organizations sharing some resources, sharing peers. They want to make sure that they cannot get into each other's accounts, right? Even though they're going to the same peer and there is multiple clients and so on. Automation's pretty big, so there's a lot of automation tools in Oracle Cloud. You use all of that with OBP because we provide REST APIs for all of the platform management, network setup, and all of the applications, sending transactions, creating chain code, event subscriptions through REST APIs. So you could essentially take all of this and you can automate them through various automation tools like Terraform Provider, Ansible collections, etc. I mentioned earlier this rich history database where we can actually take the data as data comes in from an ordering service, block comes in to the peer, and we can update the local history database, the ledger, but also asynchronously Oracle database through a queue. And then you can apply analytics and data warehousing and other things. Another thing we've done is this concept of multi-member nodes, right? So in many environments, the concept of dedicated node for a particular organization, a small organization, is too expensive, or technically maybe they're not able to manage it. So you can run a shared node, and then, of course, everybody can maintain their keys outside, private keys, through our KMS system in Oracle Cloud, and then still, sign the transactions and so on. But this multi-member node provides a lot of value in kind of a long tail, have long tail partners like in farming and agriculture, or some of the financial services as well. So this is kind of useful. I talked about the access control list already, right? So you essentially create a mechanism that allows you to store ACLs on chains. They're part of the world state, and any node on the channel has access to the same ACLs. You update them through blockchain transactions. So that's all recorded. You have full audit history, etc. And then you can invoke basically a check access function in your chain code, providing specific resource, the identity, etc., to verify if that identity that's invoking the transaction has access to the resource it's asking to update or read or query. You can specify the type of access. Auditing has been important. Some customers ask for it. One is a blockchain integrity validation, right? So this is going through the blocks and recalculating the hashes and validating the data format, ensuring blocks have not been tampered with, basically, right? So we all know that that's the core of the immutability, that we claim about the blockchain. But unless you check the blocks and verify the hashes, you will not know if somebody tampered with them. So we provide an API here to essentially do verification at the peer level. There is return success or failure once we walk through the chain and validate the hashes, and then various statistics about the ledger. We also do on-chain audit of configuration changes. So any actions related to channels, organizations, peer nodes, orders, etc., chain code, all of this are logged again as blockchain transactions on the local channels that we create. And then you get APIs to be able to either retrieve this as a full log, or you can subscribe to specific events with callback notification. So if you want to know when chain code's been installed or peer has been restarted or anything like that, you can subscribe to those kind of events. A lot of integration capabilities. So of course, standard client SDKs we support, but we also have this REST API, which I talked about. Recently, we've added this reliable callback delivery. So we make a callback on an event. Sometimes the downstream system is not responding. There is a network connection issue. We want to make sure we don't lose that callback. So we put it on a queue and we retry it and so on. We have a lot of orchestrated integrations through our integration cloud as well. And, like supply chain, track and trace application and others built a lot of this API straight in. One of the more recent enhancements is to solve this issue of transaction atomicity, right? So you need, in many applications, you need to be able to have strong consistency. And we tackled it in two ways. First is within the Hyperledger fabric itself, if you have data, if you have transaction chain codes on multiple channels, let's say you have this goods channel where you're trading marbles or whatever, and then you have a wallet channel where you're doing payment transactions, and you want those updates to be atomic. Fabric does not allow you to do that easily. Actually, natively, you cannot do that. We provided a two-phase commit implementation such that you can, through our REST API, send a transaction request, an array of operations, right? So with triggering marbles, chain code with certain arguments on channel goods, and example 02. This is a standard example for payments in channel wallet. And under the covers, we will do the two-phase prepare and commit in such a way that they are committed together, or if any one of them fails, then we'll roll back whatever we prepared. Even though from the ledger perspective, right, all of those steps are on the ledger, we don't update the actual key value state until we do a commit. So they are in a kind of a pending state, and you can see them, but they are locked. So you cannot update to do anything with them. And if you need to, we can roll them back from a world state, right? And then the transaction itself on chain will show whether it was committed or rolled back. The other things that we did was extended this when you need to update data, not only across channels and fabric, but across blockchain and databases. For example, there is, often a need to have off-chain data, right? You might have very, large volumes of data you don't want to put on the blockchain itself, documents, what have you. So if you want to do an atomic update of the blockchain metadata record and the off-chain database record or document, we now do that with full XA support. Generally, if you're familiar with XA protocols, right, global transactions, there's a concept of an external transaction manager, typically like WebLogic, JBoss, Tuxedo, WebSphere kind of solutions, right? And they coordinate distributed transactions, talking to the XA resource manager for each particular repository. So we created a resource manager library in Java for our blockchain, on top of this two-phase commit functionality, because it depends on it, to then allow those transactions to participate in global transactions orchestrated by transaction managers. And banks and financial institutions live and die by this, right? You withdraw money from one account, you update, credit to another account, that's an XA transaction. You sell a stock and you pay for it, that's an XA transaction. So in all of those cases, strong consistency is a must, and we now can use our blockchain as part of that strong consistency kind of a chain with whatever other resources. And by the way, we can accommodate other blockchains as well, even though they don't have to phase commit, because in XA protocol, we have this optimization called last logging resource, LLR, that allows for a single non-XA resource to participate in an XA transaction. Interoperability is pretty important, right? So I talked about interoperability with other Fabric nodes. We do that all the time. Interoperability with other smart contract frameworks, in addition to our native Fabric smart contracts. We run Solidity EVM and can support Solidity chain code with FAB3 client. And DAML as well, right? So DA had built this interface where they can run DAML across multiple, blockchain ledgers. So we support that as well. And then there is this cross-ledger integration where, you need to be able to do a shipping transaction on, let's say, GSBN using Hyperledger Fabric, and then maybe there is some kind of payment transaction on Corda, maybe trade finance that banks use. So we do that through Overledger, but we also started looking at Hyperledger Cactus, right? This is really a great tool that the community put together, mostly Accenture and Fujitsu, if I'm not mistaken. And we think Hyperledger Cactus has a lot of promise. So we are exploring it, trying to understand if, we can incorporate it. No, I didn't want to go to, I actually wanted to go to the next page here. So, basically, this is kind of a graphic of Hyperledger Fabric. It has this concept of a verifier that talks to different blockchain platforms through the specific APIs or plugins. And then it also has kind of a business logic plugin to orchestrate multiple transactions. So we're exploring it to see how we can incorporate it in our managed service. So our solution overall, right, incorporates a lot of things around blockchain itself, but we actually have capabilities, of course, broader than blockchain, Oracle integration capabilities, database analytics. And so we have this with one customer called wing-to-wing architectures that we often bring into those engagements with customers, where you need to integrate, where you need to be able to do analytics, and you can very quickly create, using low-code tooling, a lot of the application value out of the box. Without writing code, right? So integrations can be done low code. This blockchain app builder, auto-generated smart contracts are low code. We have a UI builder, visual builder, which is low code tool, analytics, low code, etc. All of this allows you to very rapidly create a very compelling enterprise application. So one of the key things that helps that, of course, is this automatic chain code generation, which I mentioned we do with application builder, starting with a specification file, YAML or JSON file. You can edit and tailor it, and we generate automatically the code. You can add custom methods if you want to extend it, deploy it locally. We include Hyperledger Fabric in the blockchain app builder. Locally, you can test, debug, and then you can package and deploy into your running Fabric network. It doesn't have to be Oracle network, by the way. You can deploy in others as well. You can package the chain code, deploy it anywhere in Fabric. So this speeds up things quite a bit. And we use it for tokenization support. So we've actually created fungible token support using token taxonomy framework, TTF. It originated from the Ethereum world, but it's really a good spec for defining different types of tokens. You have a template here that we created based on the definitions with different behaviors. We generate the lifecycle methods from those behaviors. You have custom properties and so on. It's a count-based token system, and we're seeing pretty good adoption. There is core SDK wrapper functions as well that we create with built-in security. So there is role-based security for minting, burning, escrow, all of that stuff. And it can be used in currency solutions, digital currencies. That's what we use for Cbdc, as well as in loyalty programs and other kind of things. And we've recently released our ERC 721 based NFT support as well, with some extensions, right? So we also generate automatically all the methods. We added burn capability because some customers need to burn custom properties that are dynamic. Any NFT owner can extend those properties cost fix metadata, and so on. And so this is now full-on NFT support that's available, on our platform, generated again from a blockchain app builder. But if you have non-Oracle nodes, you could deploy the same chain code. There is nothing particularly unique there that would not run on any other Fabric node. So with this, let me spend a few minutes on the use cases and ask Balaji to talk a little bit more about some of those. We group them into categories. So let's start with payments and securities. Balaji?
Sorry, I was on mute. Thanks, Mark. Hi, everyone. If you look at it, blockchain has come a long way since the time when it was probably a technology in search of a business problem, or rather it has been flipped the other way around. If you look at adoption of blockchain today, predominantly 50% of the adoption is around financial services, and there are a plethora of use cases. Some of them include things like payments, etc., what I'm going to talk to you about. See, today, cross-border fund transfer is a very complex process, and it's also not a very cost-effective process. Today, if you look at it, it takes about more than 3 days for money to move from one destination to another destination, and through a variety of correspondent banks, etc. So there's a cost of intermediation, which is also high. And the other thing is also the lack of visibility as to where we are. Of course, Swift has today implemented GPI net kind of frameworks in place, but all said and done, it's not a very easy process to transfer money. Everybody, if I were a customer, I would look at instantaneous transfer. So that's where blockchain comes in. So today, if you look at it, predominantly banks can look at implementing this across the variety of their overseas subsidiaries or between banks themselves. The cases which we have seen today, we have worked today, are with banks who want to essentially look at adopting blockchain for transfers among their group companies and among their overseas networks. So it could be a money transfer related issue which could come in, but predominantly what we have seen today is around non-monetary part of the money transfer is where the adoption has been there. So Swift has got a 700 series message, which is around trade finance, which also where there are also a number of confirmation messages which are being sent. So today, by routing that through a blockchain network, you essentially look at faster settlements and faster and at a lower cost. So today, if you look at it, there is a blockchain adapter which is there, which essentially puts a message on blockchain node, which generates an event, and based on from another node on another country where it resides. And that blockchain connector essentially retrieves that message, does the validation of AML, etc., also the core with the core banking check, and essentially looks at affecting a fund transfer. The benefits are everything is structured as a smart contract, so the entire routing mechanism would be through a smart contract. You have more real-time handling. Settlement is instantaneous without any intermediation costs, and of course there is a full auditability and traceability available to clients. Mark, next one. We have implemented this for Arab Jordan bank, one of the large clients in the Gulf. The other case is around security services. Today, asset tokenization is an important area. If you look at private banking or wealth management, that's also I've been a banker in my earlier avatar prior to Oracle. So there needs to be a democratization of wealth, but there are asset classes which are there, which typically have a high entry qualifiers, which are not really affordable or etc. by number of other segments. So if you look at wealth management as a segment, there is a mass affluent, there's a HNI, VHNI, and ultra HNI. Typically, the ultra HNIs is where these asset classes are form a portfolio, form a part of their portfolio. But there's a good possibility to essentially look at tokenizing these asset classes. For example, a collectible, something like a Picasso painting, or let's say something like a lunar rock, which could essentially tokenize that and look at creating better liquidity and better price discovery for that, and ensuring there is fractional ownership, and with the result, you are able to offer them to a larger section of customer segments. So what Standard Chartered did is essentially in Hong Kong is to look at tokenizing things like stock, bonds, and gold. With the result, they were able to, in Singapore, I'm sorry, my apologies, that's in Singapore, essentially to offer better, more smaller size investments to a number of their mass affluent clients, etc. and look at creating better portfolio, diversifying their portfolio and creating better liquidity for them. So these essentially, these asset classes are tokenized, they are sent to a digital exchange where they are updated onto a client account, and essentially these are connected to a variety of other platforms, and a customer can trade in that. And with the result, the entire settlement process and the execution process is structured in smart contracts, and which also provides atomic view of those transactions. The benefits are: A, you have enhanced liquidity for a client by creating you're democratizing wealth management to a larger spectrum of customer base by creating fractional ownerships. You're automating everything through smart contracts and creating efficiencies, and there is real-time settlements and reduced cost with hardly any intermediation cost which is involved. Mark, the next one.
Thanks, Balaji. Yeah, let me talk about this one. Yes, this one was in US, actually, TIAA. So TIAA is a large investment, retirement, pension kind of a financial services provider, managing a lot of funds primarily for teachers at college and school level and so on, right? So they have millions of members. And they are offering, in addition to the funds, a self-directed brokerage account, which in reality is managed by a third-party asset manager. But if you want to sell some of your funds, you can transfer the money into self-directed brokerage account, and then you can buy stocks. So it's vice versa. You can sell here and transfer money and buy funds. Well, this process is something that was very painful for them because it's an overnight file-based communication between them and the third-party asset manager who's providing the service. And they have a certain percentage of transactions where the account information does not match, or there is issues of some sort, what they call not in good order or NIGO exception processing. And then the customer will call, somebody has to spend a lot of time chasing through it, reconcile it, etc. They wanted to be able to automate account verification matching between the Omni system, which is funds management, and the self-directed brokerage platform, ensure that both balances are in good order and all of the account information is in good order. And that way they can take certain percentage, which was, I think, 2 to 3% of their transactions were in this NIGO status, and solve that. And at the same time, because they don't have to do this overnight, they could do it in real time. They can now allow people to orchestrate the trade where you could do, sell instructions from the fund and then buy instructions for particular stock, all in the same operation, right, the same day. And even in fact, you could do this multiple times a day, whereas before they couldn't. So this is a pilot they've been implementing. Consumer banking. Okay, Balaji, you want to talk through the eKYC solution?
Yeah, Mark, thank you so much. So if you look at it today, KYC is a very complex process in most banks, and not alone India, even it's the same case everywhere else as well. In India, it costs about at least 1,200 to 1,500 rupees for a bank to onboard a client. And there are multiple verification processes which are involved. So we did this, we did this project for Al Ali Jordan Bank, which is there, where today the existing KYC process was very, very laborious. It was taking more than 10 days of time to sit and onboard a client. So using a blockchain platform, we were able to shorten that out as less as 10 minutes rather. So today, if you look at it, a customer comes in and he scans his national ID card. And these are all the governmental agencies, etc., along with Al Ali Jordan Bank, etc., are part of the node. And he scans an ID card. The ID card verifies that with the national database. Then there's a completion of form. Then there's a scanning of required documents, which also gets validated completely. And with the result, there is a verification, video verification call, which also happens to activate that account. All these things essentially are instantaneous or structured. Again, the entire process is structured as smart contracts, and exchange of information is seamless between various participants. So once a verification call has been completed, then the digital KYC is encrypted, and it is stored as an encrypted file where access to other parties is available only through customer consent. Again, this is also something which is structured as a smart contract. With the result, it's a compliant KYC business which Al Ali Jordan Bank runs. in the process of they are creating better productivity, automation efficiencies which are kicked in, and also better customer experience. Mark?
Yeah. Next one, global loyalty network.
Yeah. So again, if you, for those of us who are familiar, at least I as a customer have gone through this pain. So we all have our own loyalty program. Many of the institutions offer loyalty program. For example, many of the banks offer a loyalty program both on their credit card as well as debit card. While they all help you earn points, but the pain point comes when you want to burn those points. So with the result, your avenues to burn those points are very limited. For example, I as a customer of a leading bank, I've never utilized those points because the burn avenues which are there just is not of interest to me. What if you could probably look at creating a more broader network of merchant ecosystem for both, which helps you both helps a customer earn points as well as provides them a plethora of opportunities to essentially redeem those points. This is what a Korean bank, Hana Bank, did. This is actually, they structured this for their Winter Olympics. They created a global network program where essentially they created a blockchain-based global loyalty program, which was a unified loyalty program where they onboarded a number of other banks as well, and also a number of other merchants, not alone in Korea, also across the globe. In fact, they had come down to India as well, talked to some of the Indian banks as well for this. And with the result, a customer is able to earn points. Likewise, when it comes to redeeming points, he has a number of avenues which he can do. He can swap, exchange. He can even look at putting. Of course, cryptocurrency is a bad word nowadays, but typically he can also look at converting that to points. He can look at redeeming that across a variety of avenues which are available to him. With the result, today as a customer, there is better delight and there is both better stickiness and loyalty. With the result, I as a customer would perform more transactions with the bank. Then there is, of course, there is no verification process today. Redemption is not a very real-time process in the industry. Networks like this create better risk of failure is ensure that risk of failure is low, risk of fraud is low, and create more real-time experience for redemption. And with the result, there is a better business value which is coming in. So typically, when I carry forward my loyalty program, there's a cost associated with that in the bank's balance sheet. That cost is also essentially reduced. And with the result, you are able to look at more customers doing more transactions with you. You're looking at more uptake around payment services, as well as your merchant fees for a bank is also typically increased. So this is what the Korean bank did. This is a very innovative project. And while, for example, a geography like India, what I personally feel is, while banks may have their own loyalty, banks or for that matter any other institution may have their own loyalty programs. What if they could come together and create an industry-wide platform as a redemption platform, which gives more alternatives and better choice to a customer? Mark.
Thanks, Balaji. So a few examples in business banking, trade finance, and the like. This was a solution. This was in India, built by Cargo Exchange, a partner of ours, for Ministry of Commerce, around secure logistics document exchange. So there was a significant problem, particularly during the pandemic, when export-import business involved a lot of paper documents handling. There is 36 common documents. 80% of them were exchanged as physical copies. A lot of time delays, of course, potential for fakes, which means you have to have high inspection rates and all of that. So they created a platform which is kind of became an industry standard in India because it integrates with a national stack, either for identity verification and e-signatures and so on. They have this concept of a DigiLocker where any organization, whether it's a carrier, bank, exporter, importer, customs, etc., can, upload a set of documents, sign them, and then exchange them with other participants. So all of this can be done in real time. Very simple conceptually, right? Documents exchange, but with full e-signing and ability to ensure that they're accepted by all of the other parties. So it was developed together with some banks in India like ICICI, Axis Bank, State Bank, SBI, and HDFC. And it's now being rolled out in a production environment after the pilot last year, working with the ministry. Another example, and this is in Europe, in Italy, a partner of ours, they are in financial services kind of ISV, focused on the solutions for non-performing loans. So banks need to have a lot of software to manage those loans. And they've worked with a lot of banks over the years, but they decided to get a marketplace because banks want to sell those non-performing loan portfolios, offload them, but buyers need access to information that is secure. And there is what's called the loan data tape, which is basically all of the collateral information that goes along with the loan. So that's uploaded from the bank to the marketplace. They can, anybody who wants to bid can examine that information, ensure that it's fully secure. They can do portfolio scoring, etc., auditing, and then they could do bids. And then based on the bids, the selling bank can set some rules like the highest wins or some other rules they can set as well, depending on which bids, depending on the rules, which bid will be accepted is decided by smart contract with full transparency. And then, the transaction gets actually executed between a seller and a buyer. So this is a marketplace, essentially a data marketplace, if you will. A couple examples in insurance. So this is Super Money in UK building this solution. So in insurance, it's very common to have multiple stacks, multiple silos managing, brokers and underwriters. And then you have, if you have a reinsurer, and then you have, MGAs, which is basically agent groups of agents and all of that stuff. And so the payments to them in a particular policy all get run through the different siloed systems. Super Money created a distributed ledger-based solution where all of those systems can be on the same ledger, and they tokenize those financial flows so that everybody can see exactly how any particular payment is being transacted, being distributed, etc., and all of the different participants involved in what's called bordereau screens. And it's all integrated on the ledger through the smart contracts, connecting into these various silos. So it provides a lot of real-time reconciliation capability and avoids a lot of manual data copying from one system to another. Another example is also in Italy, by the way, Smart Insurance, where they wanted to create a very low-cost policies for things like flight delay, or baggage delay, and so on, based on this concept of parametric insurance, where a smart contract can execute and determine quickly if somebody's policy actually has to pay a claim or not. So, you can check, for example, somebody has a flight delay policy, right? You can check external sites, find out, did the flight land within 2 hours of committed time or after? And then the self-executed smart contract basically can automatically trigger a payment for you based on that policy. So because this is all automated, it's very low cost, and this is a good way for all of the participants here to attract, new customers potentially with low cost policies, and then build and upsell them on other policies as well. Financial accounting reconciliation has been an interesting use case. Started actually in the companies that had multiple ERP systems, multiple lines of business in the manufacturing conglomerate. Actually, we publicly talked about the General Electric, but we very quickly found that financial companies really like the solution as well. So this is being done now by a top 10 bank in Europe. Well, it's headquartered in Europe, but it's a global bank. They have multiple ERP systems, financials ERP, PeopleSoft, Oracle Fusion ERP, and others in different lines of businesses. They have a large number of entries around the world. They operate in many countries. Each one of those is a legal entity with separate accounting. And when they transfer funds back and forth, that reconciliation process becomes very complex, and things often don't match. So they have people at the end of each reporting period on a quarterly basis or annual basis pouring through the spreadsheets and trying to reconcile things. So instead, we're tracking this on the blockchain up front, ensuring that if there is anything mismatches, it's called out right away, they can fix it. And that way, at the end of the reporting period, a lot more data actually matches, and then they have to go through the spreadsheets nearly to the same volume as they had before. So we're doing matching on the blockchain of all of those transactions across entities. Another company actually said, let's apply it to external invoices. So they have a lot of vendors, suppliers that send invoices for, like, IT consultants and such, right? They have time sheets that they collect, right? So the consultant will enter weekly timesheet data. It has to go through the internal approval process. Then receipts, basically saying, yes, it's matched and approved, goes into a Ariba system where purchase orders are to generate receipts. And then the vendor still has to submit a separate invoice into Ariba, which will then generate a payment request to Oracle e-Business Suite, and the payment will be generated. Then they have to get the payment report back and see who's been paid and who hasn't been, and how to take this gross level payment and break it down across all of these individual consultants. So very complex system. There's a lot of overhead. We created this as a blockchain implementation, the supplier nodes, internal nodes for the approvers, and then an ERP node, and essentially handling all of the data ingestion and matching across the different ERP systems, approvers, and timesheets, all using smart contracts. So I think this is going to have a lot of value in any kind of external, invoicing and complex cross ERP kind of environments. A couple things on tokenization. I mentioned our fungible tokens, right? So we have this one partner created a ticketing platform. This was for a Christmas event. They lay out this huge Christmas tree made out of lights on the lake, a couple of kilometers long. They wanted to control access, sell tickets. So this is basically a ticketing solution. And then we have another one that's interesting in the freight management, transportation, tracking and such, right? There is a lot of issues with disputes in transportation industry, a lot of administration costs, a lot of intermediates, because most carriers are very small providers. And so you have brokers and freight forwarders and so on, intermediaries involved. Tracking these things is difficult. So there is this company, it's a major industry player, basically a manufacturing company, but they're also a provider of trucks to the carriers. They have relationships there, but they're a supplier of shipping orders because they ship a lot of stuff with their manufacturing business. So they've implemented this basically logistics ecosystem. But what's interesting is that they're using our fungible tokens to charge using on-chain custodial wallets for all of the services in that environment, and using micropayment essentially to monetize this at different levels: infrastructure providers, network operators, service operators, and all of those payments through our wallets on chain are integrated into RP financials, where they could do VAT, value-added taxes, and reporting calculations and so on. So pretty cool tokenization use case. A few minutes on Cbdc, Balaji.
I think we're coming close to the end of time, right?
Okay.
So maybe do you want to quickly go through CBDCs? We're kind of actually nearly run out of time, right?
Maybe like 3 minutes and then,
no problem, Julian. Anyway, as I said, we will do a separate session on CBDC later. I'll just quickly flip through. So today, if you look at it, what's trending today in most of the countries across the world is on central bank digital currency. At least 105 countries are exploring CBDC today, and 10 very successfully launched that. The first being Bahamas. Next one. So if you look at it today, a digital currency is the same as a physical currency. So ultimately, it should be a medium of exchange. In other words, somebody can exchange that with something else. It could be a store of value. That means it has to retain its value over a period of time, and unit of account where it could be measured. So that's what sets it apart from typically your cryptocurrencies. Now, why are companies launching? Why are countries launching digital currency today? One, they want to defend sovereign financial sovereignty against cryptocurrencies. It offers a more effective and cheaper currency management system. That's what our finance minister has said. It reduces cash usage. Today in India, there's 13% of the GDP is on cash, which gets reduced. And of course, they promote financial inclusion. The barriers of adoption are around the concerns around citizen privacy. Nobody wants Big Brother watching you. Cybersecurity and counterfeiting are a major issue, with a lot of non-state actors also coming in. And of course, it could also possibly disrupt the banking model, which essentially works on banks taking deposit from customers and on lending it and earning a spread. So everybody banks with the central bank. Obviously, the deposit base of existing commercial banks will be eroded, but of course, models may be different. So if you look at what are the business models, what are the key criteria or operational considerations which needs to be looked at? What is the business model? Whether it's going to be a direct model or an indirect model? Is it going to the traditional banking route, or is it going to be a change in model? Is that what will be the delivery? Is it going to be token based or account based? What could be an adoption? Where is it going to be driven? Is it going to be driven on the retail side or wholesale side? What could be the technology adoption, whether it's conventional technology or it could be a distributed ledger technology? The key operational frameworks are around, when we look at a digital currency, what a central bank would ask is, can I control the money supply? Can it coexist with my existing currencies? Will it ensure can I ensure that there is safety and cyber resilience, which is built in? And of course, how can I roll this out, and how can I ensure adoption, and how can I ensure that the larger population is able to access the currency, and how sustainable is this? So, Mark, next one. So, if you look at from whatever our experience, what has been the typical CBDC roadmap, or what could be potential? I think most of the countries are starting out on the wholesale side and possibly moving towards the retail side. Again, wholesale side has a lot of a lot of costs which is involved. Essentially, interbank settlement. There is a settlement risk which is there, which also leads to sometimes bank failures there, especially around systematically important banks can lead to a severe consequence on the economy. So it serves to reduce settlement risk and lower operational cost. And the next step is around government securities business, delivery versus payment business, where it increases efficiencies around intraday trading by offering better liquidity management and lowers credit risk. And third stage is to look at rolling that out between enterprise B2B segment, where trade finance opportunities and other things are getting captured. And of course, there's also a cross-border element as well. Today, cross-border transactions are typically expensive. So there's CBDC. When you look at two sovereign CBDCs linking up together to offer cross-border mechanism, because it also becomes interoperable between one CBDC platform of one country and another country. It reduces remittance costs and reduces third-party dependence. And subsequently, I guess, toward the later stage, countries may look at. Of course, some countries have also adopted both, but majority of the countries are looking at wholesale and then going to retail where government to citizen payment may be a first target, and peer-to-peer payment may be another target. Mark, the next one. So if you look at technology implications, the technology implications of this are across a variety of areas. You can be felt in central banks, which are the primary players, the banks, the payment service providers, and transaction custody institutions. These are specialized institutions, which essentially, depending on the model, service the CBS, do the client servicing on CBDC, and the financial regulator. So, of course, the bottommost layer is the technology layer, where people need to, what should be the infrastructure, whether it should be cloud or on-prem, and that impacts all the three segments. What should be the distributed ledger technology or the transaction layer? Whether it could be whether it should be a distributed ledger technology or a conventional database technology. Oversight and regulatory surveillance are very important, especially when more and more things are getting digital. Obviously, the tendency for financial crimes and other things goes multifold. So that's where central banks need to really look at revamping their existing oversight mechanism and bank surveillance mechanism. And the same goes with the financial with other financial regulators as well. And applications, that's a very interesting area. Today, a lot of applications, the application area, maybe banks may need to look at better currency management system, refresh their AML platforms, and a host of other, and deploy better marketing tools, etc. And of course, there's also user experience layer where they need to build in better user experience applications to ensure better adoption of central bank digital currency. So if you look at it, broad spectrum, net, every segment is impacted, and there is going to be a real technology refresh which needs to be looked at there. Mark, over to you.
Yeah, thanks, Balaji. So yeah, we've actually been working in the space and talking with some of the major banks across Europe and Asia, Africa, US, and we've created a sandbox, basically a CBDC sandbox approach, where we can work with some of the central banks as well as some of the large commercial banks on leveraging CBDC-like capabilities. There is, obviously capabilities around the infrastructure of the blockchain platform and all of the surrounding services that we can bring together. But then there is core functional requirements, right? We generally break them into 4 areas, like onboarding, setting up the accounts, KYC, etc. There is money supply issuing and burning money and monitoring the status of the systems, the monetary statistics, velocity, etc. The actual transactions, payments between participants, and then there is regulatory aspect, fraud prevention, ML, CFT monitoring. Our tokenization solution in OBPs is built leveraging Fabric, but also integrated with a number of other things, basically provides a lot of those capabilities out of the box. From an API perspective, we can manage the token lifecycle for creation and roles management of tokens. We do need to integrate various eKYC processes, which is not a kind of country-specific step. The basic process to create, burn or mint currency. Integration with analytics I mentioned earlier provides a lot of the monitoring and reporting. Transfer and escrow methods for actual payment, and the ability to then integrate also with backend core banking systems and central bank systems, etc. Maybe RTGS systems is there as well. And then of course, we have full transaction history on Ledger. Regulators could have read-only nodes, and then we have a lot of live auditing capabilities that we can deploy as well based on variety of specific central bank requirements. And we've actually prototyped the sandbox and prototype an application. We can talk about it the next time in more details, but it includes some of those components that we talked about earlier, and it provides essentially core capabilities that a bank needs to be successful in not only deploying this on a DLT platform, but being able to manage, integrate, with their own systems. Financial participants can integrate with their core banking system. Regulators can integrate with theirs and provide bidirectional integration and so on. So the sandbox provides a lot of out-of-the-box capabilities for central banks, and we'll report more as we get deeper into some of these engagements. And some of the banks being a little quiet on it, some may be able to talk more publicly. So as time goes, just as a summary. To finish off, we also have a lot of resources that help us out in the field, and we have kind of ways of engaging with the customers throughout their life cycle. Sometimes early ones, they don't really know what they want to do; they're just interested. We can start with discovery. In other cases, they have a use case ready to go. We can help them design and implement it and prototype it as well, using our own resources, consulting partners, etc. I like this quote from Don Tapscott. We've interacted with Don in a number of conferences. He, always gets asked about predictions, right? And his stock answer is, don't ask about predictions, right? Future is not something to be predicted, something to be achieved. So go and achieve it, right? And so we've been trying to build a lot of capabilities to meet the needs of those customers, whether they're general enterprises or particular financial institutions or even central banks. So that's our journey so far, and happy to take a couple questions.
Thank you, Mark and Balaji. That was excellent. I think a lot achieved already, right?
I think we have done quite a lot.
A lot there. Very rich, list of things. So Vipin, do you want to say hi? I see Vipin's online, right? I know it's very late for you, Vipin. But I think we're nearly over time. If anyone has any questions, that please do ask. But I think, as you said, I think we can do another session on CBDCs as a follow-up to. It looks like you're doing some really interesting stuff there, right?
Yeah.
But we covered everything from trade finance to just bank reconciliation. I've seen a lot of use cases just around that. You think it's simple, but it saves so much, right? Having that one universal truth and not having to reconcile.
Exactly.
Vipin, do you want to say hello, or anybody else want to say have any questions?
Hey, hi, this is Ramesh. Just had one query.
Yeah.
So we already built the Hyperledger fabric on the DigitalOcean Kubernetes setup. The ledger has been saved into the NFS server for time being. So will it be possible to move to the Oracle blockchain platform, the existing ledger?
So we generally have been able to migrate customers with running nodes. So we can take a ledger from a running Fabric node and migrate it. Basically using the built-in Fabric gossip capability. So you add a new node and it can sync up. So do you have a running node that you can bring as a ledger up on? Or you just have the ledger blocks?
Yeah, that's great. Thanks.
Yeah, so if you have a running node, absolutely. Yeah, I mean, reach out to me and we can talk further. But if it's just the blocks in NFS, I'll have to investigate and check with our engineering folks to see what they think.
And one more question is the off-chain database, which can be used in the Oracle platform. Is there any specific database, or we can use anything?
So when we talk about off-chain, we have to distinguish two cases, right? One is the transactions come into the blockchain ledger, and we then synchronize them into an external database, and that's Oracle database. We use Oracle database for that and have specifically built that. If you're talking about storing incoming data separately from the blockchain transactions, that's your choice. You can use any database that you want for incoming data. But if you're talking about replicating transaction history into an off-chain database, then that would come through Oracle database. Of course, you can take it from Oracle database and obviously stream it or copy whatever tables into some other database if you want eventually. Does that help?
Yes, thanks.
All right,
That's all.
sure. Thanks.
Thank you, Ramesh. And any other questions from anyone else? Or anyone have any other comments? Okay, I think that was excellent. Thank you. We've run over time, so I think some people had to leave, right?
All right. Well, I'll just close on, there is a bunch of information available. You can go to our blog, blogs@oracle.com, our main page, oracle.com/blockchain, real easy. You can also try it in our cloud for free, right? We have free trial, 30 days. You can very quickly create an environment and play with it. And download
and I'm assuming they can connect with you on LinkedIn and other things and just get involved, they can reach out, right?
Yeah, absolutely. Mark.Rakhmilevich@oracle.com or LinkedIn. Yeah, you can find me.
Okay. Well, thank you, you two. I think that was excellent.
Thanks, everyone.
And I think, and let's do another one on a deeper down on CBDCs. And thank you everyone for attending and listening. Oh, was there a few other? Did I hear somebody else there? Okay. A lot of comments there. Thank you, comments. All right. Take care, everybody, and look after yourself.
Thanks, everybody.
Thank you. Thank you, Julian. Thanks.
Thank you.
Thank you.